The GuitArduino consists of many different sensors, all housed in this wooden guitar-like body, plugged in the back to an Arduino, running some code I wrote.
I was definitely inspired to make my own instrument from the Swedish band Vintergatan, which is a group of musicians/engineers that do exactly that. This is one of their videos called All Is Well. That instrument is called the modulin, which was invented by the player, Martin Mullen. And I really, when I saw this video, I decided I wanted my own. But there's no way to buy a modulin, there's only really one in existence. So I thought I would do my best to kind of try to make my own version. Rather than make it resemble a violin as the modulin does, I would make it look like a guitar. But overall it would be the same idea of this digital instrument.
Here is what I actually see as I'm playing the instrument. It corresponds to, it's very similar to the panel that you would see in front of a synthesizer, various knobs and dials that you could adjust in order to change the sound quality. You can do the same thing through software, which is really interesting. So I mapped the outputs from each of the sensors on the instrument to different dials or knobs on this panel, and I'm just going to step through each of them really quickly. So first and foremost is the pressure sensor, which allows me to change the volume based on how hard I'm pressing. Next is this joystick here that I repurposed. Now it's missing the actual stick, but it still works. That can apply pitch bend if I move it in one axis. Or it can apply two different kinds of distortion if I move it in the other axis. The first is adding this oscillator. If I move it up. And if I move it down, it does kind of the opposite. It adds a sound lower. Next, I have this ribbon sensor that's very similar to the position sensor up here, except I use it with my thumb in order to change the octave that I'm playing in. So if I press the bottom half, it will move me down an octave, and if I press the top half, it will move me up an octave. So for a given note, underneath the main position sensor that you see here is actually a force sensor. See that these two are actually a different length. The force sensor is slightly longer. And what that does is it detects how hard I'm pressing on the neck. And it changes the vibrato based on that. So you can see on the screen that I'm changing the mono and poly LFO, which really are vibrato. And that's kind of hard to hear. That's a much subtler effect. But it is interesting how we can add so many different parameters just with one instrument.
If you don't want to learn some new programming and have your mind blown, then skip the next 3 minutes, because that's exactly what's going to happen.
I said earlier that the microcontroller running this instrument is an Arduino, which takes C++ style code to program. I used a very object-oriented approach to this kind of task because there's so many different sensors, so many different variables regarding each sensor that you have to keep track of. I thought it was much simpler to kind of wrap all the information regarding each sensor into its own class. So if you look at the top here, I define a button class, a display class, which is this LCD screen that I have added to the instrument, but I actually repurposed for a different project, so it's currently lacking that. One's on the way though, so we'll get one soon. There's an LED class, which controls how the lights work. Now this one might seem overly simplified, but I was already making classes for everything else, so may as well do everything. A potentiometer class, which is how the kind of ribbon controllers and various knobs and dials output their information. And most importantly is this note class, which wraps all of the information about how the various sensors come together to produce a note. And that's done in this update note function that takes the main potentiometer, the octave potentiometer, all of these different sensors, into account when it makes its calculations. I want to show you a little bit more about how we take the information from the position sensor on the neck of the instrument and convert that to a note value, because I think this function is pretty representative of how all of the code works. So it's this function here called findInterval. It takes in that voltage you get from the neck position sensor and a minimum threshold value. This is very similar to how we tune this instrument. Rather than tuning a physical instrument where you bend a pitch until it sounds good, we have to kind of coordinate the voltage values we get at each note boundary and store them in these lines. So every time I put the instrument down and pick it up a week later, I have to modify these values, given how electrical components kind of change over time. So this value right here, for example, is the voltage we get at the boundary between a first and a second. And we go down and down. Do that for each of the 19 notes the instrument can hold at once, and store those values in this interval array. And this logic down here, it kind of takes in that the voltage we're getting from the neck sensor, and it tells us which note in the array that corresponds to. So let's say if we have a 230 reading from the neck sensor, that's going to be in between these values, so we should play an eighth. So what does that actually do? So we determined that we want to play the eighth note, or whatever note, in a given scale. But each scale is different, and we can hold 3 scales on the instrument at the same time. So let's look over here. What we're really doing is returning the index in a scale array, defined here. We're returning the index in these various scale arrays that we want to look at. Now each of these is the number of half steps in between each note, from the tonic of a given scale to a various note. So for a major scale, 0 half steps from tonic to tonic, then it's 2 half steps to get to the first, 4 to get to the second, 5 to get to the third, so on, so on, so on. Minor scale is this, and chromatic scale is this. Notice that we just increase by 1 half step each time. That's the definition of a chromatic scale. So we use the index of that we determined over here in findInterval to get the value to get the number of half. I was going to say to get the number of half steps from your tonic note to the note you want to play, but then I lost the video file and I don't want to make it again. So thanks for watching, everyone, and until next time.